Welcome back. Now I hope you have completed this example of keys, whether it's foreign key or primary key. So let's look at the answer. The red circles indicates primary key and the blue rectangular indicates foreign key. So let's take a look. Let's define again what a PK is. A PK is a primary key which is unique and not null, and also minimal. Minimal in the sense that it has the least number of fields if possible. Now by looking at the patient table, you will know that I can choose ID as a PK because all the values in this table, they are all unique and not null. Now you may ask a question, why can't then I choose name as a primary key? Because all the values in the name, they are all unique and not null as well, which satisfy the condition of a PK. Now, name is never a good choice as a primary key because, well, a person, there could be two people having the same name, but it is very unlikely to have two people sharing the same ID. Alright, so I hope you get the picture that name is not a good choice or a good candidate key. Now, look at the next table, admission. Now, when we look at the admission table, we can take a look at the patient table here. Sorry, the patient attribute. The values here, they are not unique. Yeah, you can see 102 repeats. So definitely patient is not a primary key. It cannot be a candidate. But a combination of patient and admitted will be unique. Alright, assuming that the patient, once it's admitted, will not be discharged on the same day. Of course, we can argue over this, but assume now, alright, for now, that our business rule is such that when the patient is admitted into the hospital, that patient will stay for at least a day. So therefore, we will not see that the patient and the admitted date repeat. So we'll choose that as a primary key. Then it will be unique and not null. Now, as I said, it has to be minimal, but in this case, this is the least that we need in order to make a PK. Let's look at the doctor table. In this table again, you have a choice of ID or name. So these two, you can say that they are candidate keys. Alright? But we will never choose name as a primary key, like what I've just mentioned earlier, that there could be people having the same name. So ID is always a safe and a good choice for a primary key. Now for ward as well, now even though here, it's very unlikely that the ward name repeat, right? But again, if we want to choose something that is a more efficient kind of PK, we will go for the code. Alright, so the rule of thumb of choosing a PK, we will look into things like the ID. It can be ID, the field name could be ID, could be number, could be code. So this gives you a hint that they can be chosen as a PK. But there again, we have to be careful. Sometimes if there is a repeat like this one here, then you need a combination to make it unique. I hope you have understood these 4 PK. Now let's take a look at a foreign key. Now what does foreign key say? Foreign key does not apply to every table. Alright, foreign key is derived from the primary key of another table. So now by looking at this field here, ward and ward, you can see that the values of ward, these values are found in the primary key of this table. And ward here is referring to the ward code. So even though the names are different, this will be seen as a foreign key, which is derived from the primary key of this table. Foreign key, like what I said earlier, is for linking purposes. Alright? Same thing applies here. This ward is a foreign key, and it is used to link to the primary key of this table, mock table. What about consultant? Now, consultant, if you look at the domain again and look at the set of values here, all these values can be found in the doctor table. Alright, so therefore, consultant is a foreign key which is derived from the primary key of the doctor table. Alright, so I hope we have understood this example. Now, let's do a quick understanding of the integrity rules. There are two integrity rules, which are entity integrity and referential integrity. Now, for entity integrity, it refers to the table. Alright, so in this case, if I focus on the table, then I will look at the table per se, and in this case, I'll focus on the PK. So the entity integrity rule says that the primary key must be unique and it must not be null. That's it. Now, what about referential integrity rule? Now, it says that the values in the foreign key must be found in the primary key of the other table, or it can be null. Alright? Now, as long as the values in the foreign key can be found in the primary key of the other table, then it exhibits referential integrity rules. So let's take a look at this example. Now, there are two tables here. One table here called customer and the other table called agent. In the customer table, we have the PK, which is customer code. So do you think this illustrates the entity integrity rule? Yes. Why? Because all the values in the customer code, they are unique and not null. And the same applies to the agent code field. So therefore, these two tables displays or exhibit entity integrity rule. Now, what about referential integrity? Again, referential integrity refers to the foreign key. Alright, entity integrity refers to the primary key. Now, back to referential integrity. In this case, you can see that the agent code appears here. Now, this is what I call the foreign key. Alright, and all the values here, notice that, can be found in the primary key of this table. So, this table, customer table, exhibits referential integrity rule. Right, I have an exercise for you, so please pause this video and work on the exercises. Right, here are the answers. I hope you have gotten it right. So for those four tables, you have the primary key all laid out here for you. So please check your answers with my answers here, and you can always ask in the tutorial when we meet. Now next, apart from the keys, which is the main emphasis in relational data model, another concept in relational data model is the set operators. Alright, we have got select, project, union, intersect, difference, and product. So let's take a look at each of them. Now, for select, now this select is different from the SQL select that we have been doing, which is used to retrieve the records from the database. This select basically is saying, if I select all using the set operator, then it basically retrieve all the records and all the fields from the table. Alright, this is the new table existed or created by doing a select all. So if I select only certain, if I want to select only certain rows and I impose a condition like price less than $2, then obviously from here I will only have two records that satisfy this condition, and you have got two records here which has got price less than $2. And again, another example, product code equals to 311452, which is here, And so if I just want to display only the record which satisfy this condition, then obviously I'll just get one row. Now for project is basically here, as it says, use a vertical subset of tables. So you're projecting on the various fields. Alright? So if I just do project price, then I will just focusing on the price, and that is the new table I get from issuing this set operator project. And the same applies to project product description and price. Again, projecting on the description and price. If I want to project on the product code and price, that's what I will get. Product code and price. So it's very easy. Now what about union? It says that combines all rows from two tables excluding duplicate rows. So you basically merge these two rows. So if I want to union here this particular set of records with this one, then it will merge them and then remove the duplicates. Now one thing to remember is that it must be union compatible. So what does union compatible mean? It means that if I have 3 fields in one set and the other set also must have 3 fields, and each field must correspond to each other. So if the first field is product code, then the first field in the other set also must be product code, and so forth. Now just want to do a quick understanding here. Now you can see a table as a set, alright, in case I did not mention this. A table is basically seen as a set. So a set consists of members. So in this case, tables consist of rows. So when I union these two sets, then I will have this result where you notice that the box fan, the duplicate for box fan is been taken care of. Alright, so it does not repeat here. Next is the intersect. Intersect meaning that it only takes the rows that appears in both tables. So in this case, intersection. So what do we get? We will have Franklin Johnson, this particular row, and Franklin Johnson also appears in the other set, and therefore we have the resultant, which is just a row. Right, very easy. Next, difference. So difference yields all rows in one table that are not found in the other table. So if I want to do a difference, I basically would like to make sure that all these rows here will not be found in here. Okay, so in this case, I have George Jones. George Jones is not found here. That's great, so it's displayed. Then same thing applies to Jane Smith. What about Peter Robinson as well? It is not found here. Now Franklin Johnson is found, so therefore it's not appearing. Martin Lopez is not found in this set, therefore it appears. So it's basically removing all these rows that is found here. If it's found here, then don't display. Product. Now product is something that is worth understanding, because when we try to join the two tables, alright, now product basically in this situation, it just join them, merge together mindlessly. So here I have 1, 2, 3, 4, 5, 6 rows, and there are 3 rows here. So 6 times 3, you will have 18 rows here. Alright, so product basically take the first row and then join to the first row here, and then take the first row again, join to the second row, first row again to the third row, and so forth. And that's why you have all this. And sometimes this is really mindless because it may not be correct. So we have to be very careful when we make use of product operation.